Hello all. In this session, let's dive more deeper into this descriptive analytics. What is this descriptive analytics? Descriptive analytics, by collecting the data, after collecting the data, it will be able to give you the insights such as trends, patterns and the features that actually are contributing to some event that actually has happened in the past. That is what a descriptive analytics. Right after the data set has been collected, by using the descriptive analytics, we will analyze what happened in the past and what are the events that are contributed towards this event. What are the things that contributed to this event? What exactly is the pattern? This is all descriptive analytics. Let us understand some key characteristics of this descriptive analytics. So to start with, it helps answering the questions what happening or what is happening or what already has happened. When you get a data set, when you analyze, you will be able to know what happened. It also will be able to tell you what exactly is happening currently, concurrently. Okay, for an example, weather forecasting. In the weather forecasting, by understanding the past data, you will be able to know what is the current today's weather, right? Now let us understand a few key characteristics of the descriptive analytics. The first one is summarizes the historical data. It is going to collect the historical data. Let us take weather report. From various sources, the historical data will get collected, and right then it is going to reveal the pattern. At what times, what is the timeline for having the hottest time, rather the hottest period, such as May or June. What is the time when the events such as cyclones are happening? And at the same time, when a cyclone happens, what is the pattern? Meaning, how often the cyclone is expected to be repeated, rather what exactly is the timeline of a cyclone? Okay, that's what that pattern. What is the trend? Trend meaning when the cyclone comes, for how long it sustains, for how long it sustains and just sprawls across, it spans across. That's what talks about trends. And the behavior. How much area will get affected? Rather, how intense is a cyclone that happens at a specific month? That is what all about patterns, trends and the behavior. When you collect a data set and you analyze, you will be able to understand the pattern and the trend and the behavior. What is the pattern? Maybe the timeline, maybe associated to the timeline. In the example of a weather report, the timeline of a specific event, hottest month or the cyclone that happens. Trend, for how long the hottest months, the duration of this hottest period of the time or the hottest period of the year. Trend, behavior. When this cyclone happens, how much square feet of the area will actually be impacted by this cyclone? Okay, we'll be able to understand. Data aggregation and summarization. What is aggregation and summarization? The data will be collected from various sensors, right? With respect to the weather forecast, data will not just get collected by one sensor. There are several sensors associated or positioned across geographically in various places. We're going to collect the data from many sources. The collected data should be aggregated in the form of a table or in the form of something else. This is what? The aggregation. And an understandable format, which also is going to offer you the insight. You should be able to understand and analyze. You should also be able to get the insights from this. This is what? Data aggregation and a summarization. Often it's through tables, charts or reports. Charts will be helpful for our cyclone model, right? That weather forecasting model. The charts are more helpful. Use a simple statistical model. It typically involves in basic statistical method like averages, percentages, counts, ranges and summarizes the data. For example, in the month of May, what is the average temperature? When you want to visit a hill station, when you try to get the demographics of the hill station from the Google, what it will tell you? The average temperature in the May. That is what average. This is what the statistical, the detail, the statistical aggregation. It is going to provide you the insights, the statistical insights. What are this? The simplest statistical methods such as averages and the percentages. The percentage of, I would say, the percentage of rainfall. Will that actually contributes towards the decision making. Write the counts and the ranges to summarize the data. Then identifies the patterns and trends, which we already discussed. Supports decision making. Needless to say, why do we require data analytics? The data analytics supports us with the decision making. What is decision making? For an example, in the past history, Zomato share is not performing well. The guy who actually is interested in Zomato purchasing the Zomato share, he will observe the previous trends. Right after he analyzes this, he will be able to take a decision in between yes or no. Right? And similarly, when a cyclone is about to commence, what will be the precautionary measures to be taken? That's what we understand from the data that is available. It just helps us in the decision making. Visualization and reporting tools. What are the visualization reporting tools? Right after you collect the data, to have more insights, more in-depth insights, we will need some visualization tools through which, let us say, heat map. What is a heat map? And the globe, in the map, in the demographic map, geographic map, there will be something called heat map. What is a heat map? Heat map intensifies those geographical area where there is a heat wave. Similarly, heat maps can also be used in several other fields. When there is a zone that is heated, like the color is somewhat in between red and brown, that is intensified. The pattern is intensified, such as a heat wave passing through. The heat map just not in the weather forecasting. We also are going to use the heat map in some other domains also. But heat map is going to tell you how intensified is a specific feature within that map. Okay, heat maps and charts. Charts, we often use charts. Okay, the bar charts. What exactly is the pattern? Now, to understand the patterns, we use the bar charts. Data mining for insight extraction. Data mining is next level. When we collect a huge data, we will use data mining, but that is irrelevant for today's thing. Now, let us get into a detailed explanation or a detailed example of this data analytics, predictive analytics. Okay, descriptive analytics, bigger pardon, descriptive analytics. The first thing that we are going to discuss is the frequency distribution. What is this frequency distribution? Understand. I am going to demonstrate this frequency distribution. I am going to collect a data set. What is the data set? We have a data set with the following ages of a group of 15 people. There are 15 people in this data set and their ages only are present within the data set. These are the ages. Okay. Now, there is some technique called frequency distribution. The frequency distribution will be able to identify, through the frequency distribution, we will be able to identify the unique values within a data set. What are the unique values? The unique values that only are present within the data set. Okay, so I'll give you an example. For an example, 22 is a unique value, 25 is a unique value, so is 27, so is 30, so is 35. Means in the ages, the data, only 5 values are present. What about the other? Because we have several ages, right? All are the repetitions. All the other are the repetitions of 22, 25, 27, 30 and 35. What are the unique values? Only these values are present in that array of the data that we have collected. These are the unique values. Now, what is frequency distribution? Frequency distribution tells you how frequently a value is being repeated in the data set. For example, 22 appears for twice, 25 appears for 5 times, age 27 appears for twice, and 30 appears for 4 times, 35 appears for 2 times. Simple. What is distribution? Distribution tells you how frequently, rather how repeatedly a data point or a data element occurs, data item occurs in a data set. Here, with respect to the ages, we have 15 ages, 15 distinct ages, but only there are 5 unique values. These ages are respect to some people, but there are only 5 unique values. The remaining all just repetitions or replicas of these values, such as 22 is for twice, 25 is for 5 times, 27 is for twice, 30 is for 4 times, and 35 appears for twice. Okay. Now, right after we extracted, to visualize this, to provide the insights, to get the insights, we should be able to tabularize. What is tabularize? We start going to present a table for this. In the table, age and the frequency. It will give you the complete frequency distribution in this case. Okay, the table show how often each age occurs in the data set. The age 20, for example, is the most common age. This is the insight that you're getting. We're simply not creating the table for some the invalid reasons. Here the frequency distribution will point you around 25 because the 25 is the most common age. In that specific data set, most of the people are in and around 25. For an example, this data set is being collected for some medical purpose. Then corresponding actions can be taken with respect to this frequency distribution. For an example, the COVID, the dose, the COVID injection dose. With respect to the ages, dose should be adjusted. For that, we need to collect the data set. What are the various ages of the society? Right then, we will be able to get the doses. Okay, the vaccine, COVID vaccine, I hope you already got it. Some people are given twice, some people only are given for once. Less than 30 years, one dose is enough. More than 30 years, there actually are required 2 doses. And similar to this, the decisions will be taken based on the insights that's been retrieved from the frequency distribution. Here the frequency distribution is, pointing you around 25 here. To visualize a bar chart or a histogram, we also can use a bar chart or a histogram. You know what is a bar chart, and you also can use a histogram. In the bar chart, there is a x-axis and y-axis, right? You also quickly identify which ages are most common in the group. Bar chart, it is even more better than the table. By using the bar chart or a histogram, we'll be able to understand which data point is repeating on a x-axis and y-axis. We are going to use x-axis and y-axis there. Okay. Now, another example, in a survey about favorite fruit among 100 participants, the frequency distribution might look like apple 40, banana 30, orange 20, and grapes 10. So, here the thing is, likes and dislikes of a people. Which fruit you like? Here, where exactly we are moving around? On what data point we are moving around? Obviously, the apple. Okay, you want to analyze the trends of the people, which fruit they actually, you want to start a fruit market. In the fruit market, which fruit you need to get more? Obviously, the apple, right? Okay, this is how the frequency distribution is going to give you an important detail of how frequently a value is actually being repeated. That's what the frequency distribution. In this distribution, the apple most popular chosen by 40% of the people. Okay. In the next session, we are going to understand about the measures of centrality.